Working with rational exponents. What does it mean if it's a rational number? I'll say a rational number means you can write it a certain way. I'll say this should be a middle school vocabulary word. What is a rational number? It's not opposite of a prime. Those are called composite numbers. If you guys don't know it, Google it real quick. What is a rational number?
Isn't it a number that can be written as a fraction?
It can be written as a fraction. All right, so I do want you guys to see what's that word inside of rational? Ration or even ratio. How do we write ratios? As a fraction. All right, so these are exponents with a fraction. All right, so you will see things today. So you'll have a base, and then your power is going to be a fraction. All right, and the numerator and the denominator in the fraction both have a meaning. The numerator of a power is simply the power. So if you see something that says like base 2 and the numerator is a 2, that means square it. If it's to the numerator is a 3, that's to the third power. So in your power, that is your numerator. The bottom, or the denominator, is what we call the root. So we've dealt with square roots, and I'm sure at some point in your life you've maybe dealt with cubed roots. So the numerator is the power, the denominator is the root. All right, and then this is what we call, this is what we call exponential form, because it's written with an exponent. Now, sometimes whenever you see the word root, not all roots are square roots. We actually can change it to radical form. And a radical is just that symbol. So whatever the base is, so in this case the base is A, the base is actually going to go inside of the radical, and then the power will stay in its spot, and then whatever this root is, it actually goes there. So we are going to at first learn how to go from one form to the other. So I'm going to give you guys examples first. So example 1, we're going to go from exponential form to radical form. And I'm just going to abbreviate. Exponential form to radical form. So we are taking something to a power that is a fraction, and we just want to rewrite it with a radical. I will tell you, most of the time when you're simplifying, you want to write it in radical form. It's a little bit more helpful. So if we are looking at this, the base is whatever we're taking to that power, and in this case the base is in parentheses, it's 5n. So our 5n is going to go inside of the root or the radical. Now, which number in my power is the actual power? Is it to the first power or is it to the second power? I'm going to say the power is the numerator. So my power is 1. So it goes at the end as the exponent. And then my 2 is the root. And so the root is going to go here. Now, I will tell you, what's anything to the first power? Like, what's 5 to the first power? What's 7 to the first power? Do you have to write that first power? So I do want you to know that when you write this, those two things mean the same thing. So with exponents, the first power doesn't really change anything. Anything to the first power is just itself. And then whenever we're writing roots, whenever we just write a root by itself, that means square root, and isn't square root when we want to find something to the second power. So that second power or that second root, you can write the 2, but you don't have to write the root if the root is 2. It's one of those understood roots. So the root of 2, you don't have to write it, but you can if you would like. Now let's do one that has a different root other than 2, because this one you definitely would have to write. All right, we've got 4y, and our exponent here is 5 over 3. All right, so what are we going to write inside the radical? y goes inside. Now, which number is the power?
3.
Are you sure about that? Okay, 5 is the power. So the power always goes at the end. It's your exponent. Now, where does that? The 3 is the root. So it just goes right there. All right, last one. I want you guys to try this one on your own. If I just tell you to rewrite that, how would we rewrite it? All right, so AA goes inside the radical. All right, what number goes here for my power?
3.
All right, my power is 3, and what's my root? 4. All right, how many of you guys think you could do those on your own? I'm going to say they're pretty easy, right? Now, just like sometimes it's beneficial to go from exponential to radical form, I will say in some cases it is nice to use exponents. So for our second example, we are going to go from something that's in radical form and change it to exponents. All right, on this one, what's our base? I'm going to say, what's the base? The base is always what's inside the radical, but what is that? All right, it's v to the 5th. It's inside. Now, on this one, whatever is inside the radical, you want to put parentheses around it. Now, what's the power if there is no exponent outside? It is a 1, and my root is 3. And if you want to take 5 times 1/3, because you do multiply powers when they're like that, you can also write it like that. Those two are equivalent. So v to the 5th is what's inside the parentheses. And then we take it to the 1/3 power because that 1 is there, we just never write it. To the 1/3, in which 5 times 1/3 is 5/3. All right, our second example, whatever is inside the radical gets written in parentheses. So in this case, it's 2x to the 7th. Now what's my power here if it's not there? If there's no power there, it is a 1, and my root is 6. Now on this one, we have multiple. We are supposed to take 2 to the 1/6 power and 7 to the 1/6 power. On this one, I'm actually okay with you leaving it like this, just because there's multiple things that need to be taken to that exponent, and we don't have to go there. Now, I will tell you, this is 2 to the 1/6, and then x would be 7/6. If you wanted to expand it out, that's what that would be, but that's not what we're doing here. All right, now for the last one, I want you guys to try this one on your own. Sorry, it's not focusing. There we go. Cubed root of 10x squared. All right, how'd you guys do on that one? All right, are there any questions on those? Now, I do want to ask you one thing. What if I put a 4 right there? Where would that 4 go? It would go where the 1 is. Very good. All right, I actually think we are ready for the last part. All right, so now we are actually going to simplify with rational exponents. But before we start simplifying, I do want you to know that that cake method that we use to simplify square roots, we can also use that for other roots as well. All right, so we can use the cake method with other roots. So if you know one of these roots mentally, I'm totally okay with you just telling me what it is. But if you don't know, for example, the 5th root of 32, there is a way to find that. All right, so I just want to review. All right, so when you see just this, what does that tell you to calculate? That means square root, right? All right, what is the square root of 64?
8.
All right, it's 8. Now, I want you guys to think about this for just a second. All right, you just told me that's the square root. So if it's a square root, we're trying to find something to the second power that comes with 8. So what this means, square root of 8 really means that the root is 2. So when I cake 64, when I'm doing square roots, we circle pairs. So like you guys would have done this. You would have taken 64 divided by 2 and got 32, divide by 2 and get 16, divide by 2 and get 8, divide by 2 and get 4. All right, so we've got a lot of 2's. So we have 1 pair, 2 pairs, 3 pairs. So then 2 times 2 times 2 gives us our 8, correct? So whenever it's a square root, we circle pairs. We can also do this with the cubed root of 64. So we still cake with the prime numbers like we would, but instead of circling pairs in a third root, we're going to circle groups of 3. So instead of looking for pairs, we're going to look for things that there are 3 of, groups of 3. So same thing, 64, divide by 2, all right, so the caking process doesn't change, but we're not looking for pairs of 2 now, we're looking for groups of 3. Do you guys agree I have 2 groups of 3 there? So same thing, every group is just a number. 2 times 2 gives us 4. Now, another way that you would want to simplify this is you just want to ask yourself what number to the third power would give me 64. And 2 times 2 to the third is 8. You could do 3 times 3 times 3, that's 27. 4 times 4 times 4 is 64. So if you know that cubed root without doing the cake method, I'm okay with that, but that's how you would do that if you're not for sure. All right, and then the last one I want to do is no, I think I'm good. I think I'm good with this. All right, let's actually do some work here. All right, so the first one I want to simplify is 16 to the 3/4 power. So we want to simplify this. All right, so whenever you're simplifying, the first thing you want to do is you want to change it to radical form. All right, so inside the radical is my 16. Now, which number is my root? The 3 or the 4? The 4 is my root, and the 3 is my power. So we're going to simplify the root first. Do you guys know what the 4th root of 16 is? I'm going to say it's not 4, because would 4 times 4 times 4 times 4 be equal to 16? All right, Ian thinks it's 2. What about 2 times 2 times 2 times 2? Would that be 16? All right, so it is 2. And then we would take 2 to the third power, which is 8. 2 times 2 times 2. So if you did not know that the 4th root of 16 is 2, you could do the cake method. All right, and if it's a 4th root, we're looking for a group of 4, and if you can see, my group of 4 is just a group of 2's, so we got 1 2 to the third power. Let's try another one. 125 to the 1/3 power. So just like we did on the last one, we want to convert it to radical form. Now, which number is my root? 1 or 3? 3 is my root, and 1 is my power. I'm going to say, does anybody know the third root or the cubed root of 125? I'm going to say, what number could I multiply by itself 3 times to get 125? It is 5. And 5 to the first is just 5. So same thing, you could cake 125. And if you can see, if we're looking for the third root, it's a group of 3. And so it is 5 times 5 times 5. So 5 to the first. All right, this is our last one, and then I'll let you guys try some on your own. 27 to the 4/3 power. So 27 goes on the inside. What's my root? Right, root is 3, power is 4. You say, what is the third root of 27? 3. Now, does anybody know 3 to the 4th? 3 times 3 times 3 times 3. So you know 3 times 3 is 9, right? And then another 3 times 3, 9 times 9 is 81. All right, I know it's a sleepy, rainy Monday morning, but do you guys have any questions? Now say, have you guys done rational exponents in middle school at all? Now say, what do you guys think? I'm seeing some head nods and some shoulder shrugs. Is this a good thing or a bad thing? Okay. All right, so I do have a few for you guys to try. And then tomorrow we will have some where we'll use our exponent rules and like when to add and when to multiply. But today was just an intro, and then tomorrow we'll do a little bit more with it, and then same thing on Wednesday. So your assignment is on Canvas.